Welcome back to the classroom. My name is Mr. Wong. Today we'll explain another exam question. This is from the additional sample paper for Module 5, question 13. So don't need to really say too much, but just remember this is for Module 5, inquiry question 2, which is on circular motion. We have a horizontal disk that's rotating clockwise on table when viewed from above. Two small blocks are attached to the disk at different radii from the center. Draw a diagram, so we want to draw a diagram of this scenario using vector arrows to show the relative linear velocities and centripetal force. So we want to show the relative, just get rid of that. We want to show the linear velocities and centripetal forces for each block as the disk rotates. Okay, we can even do it in a different color. So each block as the disk rotates, that's our priority here. Okay, so draw a scenario. So let's draw a nice circular structure because we're on a disk. I'm going to label this as the rotating disk. We also know our disk is rotating clockwise, so it's going in this manner, rotating around like so. And we have our center point, so we'll say that's the center. We have block 1 here. Okay, and we have block 2 here. Okay, so B1, then we have B2. Okay, so what we need to do is draw vector arrows to show the relative linear velocities. So of different radii. So actually we'll change it. We'll say B2 is closer towards the center, while as B1 is further away from the center. So you can see that very clearly here. Okay, so what we're going to do next is we're going to show the difference in linear velocity. So we'll do that. We'll also label it as V. Okay, what we know from centripetal force formula, okay, if the radius is small, because velocity is directly proportional to radius, if radius is small, velocity is also small to maintain the same centripetal force. If the radius is large, then the velocity is also large. So this one, we should expect that the linear velocity is bigger than this linear velocity over here. Okay, so there's that. The last thing we need to do is show for our centripetal force. Okay, and then the last one we have is our centripetal force. That goes in like so, and that would also go in like so. So the lengths should be about the same in terms of the centripetal force. So that's what we have there. Oh, actually, let's just change one thing very quickly, and that's the centripetal force. So we actually know that same idea with this formula we have here. As the radius is smaller, okay, there is less centripetal force required to pull the object in, okay, because it's moving slower. If the object was moving faster with a larger radius, then you need a stronger centripetal force to pull the object back in. So just redraw that one. So we'll draw this one, larger centripetal force, whilst this one is a slightly smaller centripetal force coming in like that. And that's how you show how you perform this question. And that's the relationship we can sort of show by to demonstrate how linear velocity and centripetal force relate with each other on a rotating disk. Might also write rotation direction. to represent that this is going clockwise. If you found this video useful, give it a like and subscribe if you haven't done so already. And thank you for listening. I'll see you next time.